Hello and I want to welcome you to Graphing Piecewise Functions. Here we have the set of instructions on how to graph these, and they include let x be the value in the cutoff of the domain, substitute this value into x of each of equations. These will make one of the equations true, graph with a closed circle. This will make one of the equations false, graph with an open circle. Choose at least one value of x that meets the criteria for each equation and find the corresponding y values. Plot these points. Okay, so first what we need to do is say that our domain is at 0 here, it looks like. So we have x equals 0. So we're going to write our equation. We have the first one of f of x, we're just going to include this 2x. So what we need to do is say f at 0 is 2, and in place of x just write 0, and what that's going to yield is 0. And that will give us the point 0 because that's what x is equal to, comma, and the value we just found, which is a y value, or an f at some value for x, which is 0. And this will not be included. Not included because it did not have the equal sign in the inequality of the piecewise function. What that means is this part right here, there was no equal to, it was just a plain inequality symbol. Okay, and now what we want to do is have f of x for the second part of the piecewise, for the negative 2x. And now what we'll do is we'll write f of x, where we'll have f of 0. So every time there's an x variable, we'll write 0 in its place. And just as before, it too will yield 0. So that gives us the x value of 0 for coordinate, comma, the value we just found, which was 0. Okay, what's important to note here is that this will be included. And that means this inequality right here had the less than or equal to part. That makes it included. And that means it will be symbolized by a circled in dot, while the not included will be a plain open circle. So we have the first three bullets taken care of. So now we have to choose at least one x value that meets the criteria for each equation and find the corresponding y values. So for the f of x at x equal, f of x is 2x. This first part, we had to find something that is less than x. In this case, 0. Less than 0. So what I would choose would be I would probably go with a negative 2. So let's let x equal negative 2. So we're going to have f at negative 2, because negative 2 is less than 0. So 2, replacing the x with negative 2, yields the point, or yields just negative 4. So gathering these points, we have negative 2, comma, negative 4. So, for our first part, we know it's going to be an open circle because it's not included from our first part of the problem. And now we know another point. So 0, 0 is an unincluded point. Now we have negative 2, negative 4 as our second point. So now what we're able to do is to connect the points like that. And now, for our second part, to get the other half of the inequality in the piecewise function, what I would try to do is f of x at the second inequality of the piecewise function of f of x equals a negative 2x. x. So in this case, I would find a point that is greater than or equal to 0. So, and I would probably not want to choose 0 because we did that before and we just get the point 0, 0. So let's say x is equal to negative 4. Well, let's say x is equal to 2. Excuse me, because 2 is greater than 0. So the function at 2 of negative 2 times the variable, which we'll replace with 2, gives us negative 4. So we'll have the point 2 for x and then negative 4 in for our y value. So we plot that. We have 2, we go down to 4, and that makes our second point. Okay. So we know that this part of the inequality is included because of this part right here. It has the equal to. So we actually can fill in that inequality, even though that part was not included. The part that was included makes up for it. We're just going to connect that part of the piecewise function. And as you can now see, this piecewise function has been graphed, and this gives us justification that this is what the graph will look like.